Welcome to the Digital Identity Digest, the audio companion to the blog at Spherical Cow Consulting. I'm Heather Flanagan, and every week I break down interesting topics in the field of digital identity, from credentials and standards to browser weirdness and policy twists. If you work with digital identity but don't have time to follow every specification or hype cycle, you're in the right place. Let's get into it. Welcome back. Now, if you spend any time in the digital identity or payments or policy world, you've probably felt the shift in conversation when it comes to digital wallets. I mean, what used to be a lot of sort of future-looking architecture diagrams are now showing up in regulation, in procurement plans, and in very, very real product roadmaps. Now, I was reminded of all of this fairly recently at a conference I was helping organize called Trust and Internet Identity Middleware Europe, also known as TIME, where wallets were a really hot topic of conversation for the research and education community. Now, there was one session in particular on zero-knowledge proofs that I found fascinating, and I understood. This was not a session for cryptographers, it was for everybody else. And it wasn't about the math, but it was about the deployment questions that are getting very real very quickly when it comes to zero-knowledge proofs, selective disclosure, things like that. So this post is definitely less about the magic of cryptography and more about the design decisions that teams are now being forced to make. Now, I was amused to look back and realized I wrote about zero-knowledge proofs exactly a year ago from a higher level perspective, focusing on their promise and some of the practical concerns around cost and accessibility. But what's become clear since then, especially as wallet deployments move closer to production, is that there's more interesting questions that are like increasingly architectural to just how our wallets are going to work. So these questions are like, where does the complexity live? How is correlation risk managed? And how do these systems behave at scale? This is all front and center stuff. Now, just first, I want you to remember that digital identity wallets aren't always distinct from digital payment wallets. Several platforms are already combining the two, but they can be separate, and in many deployments they are. Now, regardless of whether payment data is involved, the important point is that digital identity wallets are becoming real infrastructure. And you can tell because they are being written into regulation. Looking at you, EIDAS 2.0, right? They're showing up in national programs, and they're increasingly being used by real people in everyday scenarios. Now, even enterprises, but especially in finance and other regulated sectors, they're starting to treat wallets as something that they will need to support, not just monitor from a distance. And that shift changes the design conversation. It means designing for operational reality and not just a minimal viable product to prove whether or not it works. Which brings us to one of the many, many architectural choices that teams now face. When it comes to the data being held in a digital wallet, should systems rely on something called the selective disclosure, or zero-knowledge proofs, or some combination of both? Right. Now, this question is getting more attention because wallet deployments are moving out of pilot and into regulated high-scale environments where privacy, performance, and operational cost are all colliding. The cryptography choices that felt kind of interchangeable in early prototypes are beginning to have some really interesting architectural consequences. Now, before I just keep going down the comparison path, I want to start with a little bit of terminology just to make sure everybody's on the same page. So these phrases, selective disclosure, zero-knowledge proof, are not always used precisely. They're sometimes used interchangeably, which is actually wrong, because they do describe different technical mechanisms, right? Selective disclosure refers to the ability of a credential holder to reveal only specific attributes from a credential rather than presenting the entire data set. So a verifier might learn that someone is over 18, lives in a particular jurisdiction, or holds a given certification without receiving their name or any other kind of information like that. Now, in many current deployments, this is achieved through cryptographic techniques that allow for partial disclosure of credential data. Now, in zero-knowledge proofs, or ZKPs, these are a broader class of cryptographic protocols that allow one party to prove a statement is true without revealing any of the underlying data used to prove it. In wallet systems, that often means that the holder can prove what's called a predicate, like over 18, without revealing the birth date itself, and sometimes without exposing a stable identifier that could be used to correlate across the different transactions. And this is an important overlap between these two things. In many modern credential architectures, selective disclosure is the goal, and zero knowledge proofs are one increasingly powerful way to achieve that goal. Other implementations rely on more traditional signature schemes and structured credential design, right? So there's different paths to get to the same thing. And to be very clear, selective disclosure and zero knowledge proofs are not mutually exclusive. Many production architectures will, in fact, use elements of both. So it's not really which one is better or which one wins. The real question is, where does the complexity live and how do the systems behave when you try and run these things at like national scale? Selective disclosure became the early favorite for some really good reasons. I mean, conceptually, it's easy to explain and aligns well with the existing credential models. Instead of presenting a full credential, the holder reveals only what's needed for the given transaction, proof of age instead of birth date, proof of employment status instead of a full personnel record. And from a data minimization standpoint, it's clearly better than the hand over everything patterns that have dominated the earlier identity systems. So in many controlled deployments, that worked quite well. But, and this is where things start to get interesting, the implementation details mattered a whole lot more than that headline capability. In many current ecosystems, selective disclosure is implemented through what are called structured issuance models. Basically, issuers anticipate the future presentation needs and produce credentials or credential variants accordingly, right? This structured selective disclosure approach can work effectively at a modest scale, where basically they are minting out in batches the credentials that need to be used for the more common use cases. Now, it is worth noting that not all selective disclosure schemes require this kind of credential structuring, but several widely discussed large-scale architectures do rely on it today. Now, at national or cross-border scale, this approach begins to introduce some really interesting operational weight because more credential variants can mean more issuance overhead and more revocation complexity and more lifecycle management to keep everything synchronized across the ecosystem. And there's another quieter privacy consideration. Structured selective disclosure reduces what is visible in a single transaction, but depending on how identifiers and cryptographic material are handled, it does not always eliminate the possibility of correlation across transactions. This becomes particularly relevant in scenarios where the entity issuing the credential and the entity verifying the credential may collude, or in some government and enterprise deployments, are actually the same entity. Now, in those environments, linkability can emerge even when individual disclosures appear to be minimal. And for some deployments, okay, that's fine, whatever. But for others, particularly those operating under strict data protection expectations, that's a much more significant design concern. Now, zero knowledge proofs, those techniques approach the problem from a different angle. Instead of relying on pre-segmented, pre-structured credential variants, the issuer signs a credential one time. The wallet then derives the proofs dynamically, locally, demonstrating only what's required for a given transaction. So, in some cases, this reduces disclosure all the way down to a predicate of over 18. In non-interactive models, this can happen in a single exchange, which is really appealing for web scale and cross-border environments. So, but the most important architectural shift there is not just about what gets disclosed and whatnot. It's about where the system complexity has now moved, right? If structured selective disclosure models concentrate complexity in the issuer and ecosystem governance layer, then zero knowledge proof enabled approaches push more responsibility into the wallet and the user's device, effectively allowing something like selective disclosure to be computed dynamically rather than prepackaged at issuance time. That's a big deal. Efficient proof generation on constrained devices is actually an engineering challenge, right? You've got things like holder binding, pseudonym strategies, hardware support, cryptographic agility. They all require careful design, and equally important, ecosystems still need to determine how confidently they can establish that the entity presenting the credential is the legitimate holder, basically the holder binding problem. But distributing the work, moving it away from the issuer and into, the wallet, the holder, it does change the scaling model. So instead of concentrating computational effort in a national backend system, the load is now spread across millions of devices. And at very large scale, that distribution is not just a technical preference, it's actually a sustainability decision. Now, there's one caution I want you to keep in mind with the zero knowledge proofs, because I think in some cases it's probably really attractive that that's not happening all centrally at the issuer, right? Do remember that zero knowledge proofs are going to absolutely faithfully amplify the semantics of the underlying data. That means if the input credential or the token structure or the claim is poorly defined, the proof will still verify it as valid. It will simply be proving something that's less meaningful than anyone wanted. So, in other words, zero knowledge proofs strengthen well designed systems, but it doesn't rescue weak ones. If your data is bad, then it will say, yes, this is absolutely your bad data. Congratulations. It's also worth noting that revocation and status checking remain active areas of engineering work for privacy preserving credential systems, particularly where offline or low latency verification is required. The industry is making progress here, but the trade offs are still very much in motion. One of the more subtle issues in digital wallet design is what's verifier correlation. So even when an individual transaction is well minimized, linkability can emerge over time if the same identifiers or cryptographic material appears repeatedly across contexts. Now, some structured selective disclosure deployments attempt to mitigate this by credential segmentation or through batching, and that can help, but it helps at the cost of additional operational overhead. Now, zero knowledge proof enabled selective disclosure offers an interesting, more structural response, and properly designed systems can derive per verifier pseudonyms or unlinkable presentations from a single underlying credential. For regulators and ecosystem designers thinking about privacy by design, this is often where the conversation becomes a lot more concrete, and it becomes less about any single transaction and more about what can be inferred over months or years of system use. So reducing, the number of attributes is good, but reducing structural linkability is even better. Of course, cryptography is only part of the correlation story here. Business logic, verifier behavior, network metadata, and other user patterns can all reintroduce linkability if the broader system is not designed with equal care. And of course, none of this is free, right? It would be a mistake to present zero knowledge proof approaches as, this frictionless upgrade path, because they are not. Different constructions will come with different trade-offs. Some are efficient, but raise longer-term cryptographic questions. Others are more future resilient, but they're computationally heavier, right? So yes, maybe it's going out to the device, but does the device have a GPU that could actually cope with it? Hardware support is uneven, and secure element compatibility is something that's still evolving. Selective disclosure, for its part, benefits from being closer to many existing credential and signature models and from having more deployment experience today, which was a long way of saying both paths involve real engineering challenges and real trade-offs, which is exactly why wallet architects need to think beyond the minimal viable deployment. Wallet deployments are moving really quickly, especially in Europe. Certification regimes are forming, browser behaviors continue to shift, enterprises are starting to run real risk analyses instead of just pilot experiments, and in that environment, it's tempting to choose, well, what works today, and then defer the harder architectural questions because, you're on a schedule, you got to do stuff, right? But you have to remember that digital wallets are not short-lived features, right? These are becoming part of the identity substrate of the internet and of regulated digital services. Most mature ecosystems will likely use both selective disclosure and zero knowledge techniques over time. The goal here isn't purity. The goal is our systems that will behave well under real world pressure. So the real design challenge is making sure that the architecture can evolve without creating unsustainable operational or privacy debt. Because once these systems reach national scale, changing direction becomes significantly harder. And as always, in identity, your mileage may vary. Different sectors, regulatory environments, and risk tolerances will land in different places on the spectrum. But the sooner teams start evaluating where the complexity, the correlation risk, and the long-term operational costs actually sit, the better position they're going to be to when today's pilot architectures become the actual infrastructure you're relying on tomorrow. Thanks for your time. Tune in again next week. And that's it for this week's episode of the Digital Identity Digest. If it helps make things a little clearer, or at least a little more interesting, share it with a friend or colleague and connect with me on LinkedIn at HL Flanagan. And if you enjoyed the show, do be sure to subscribe and leave me a rating and review on Apple Podcasts or wherever you listen to podcasts. You can also find the written full post at sphericalcowconsulting.com. Now stay curious, stay engaged, and let's keep these conversations going.